Python Testing and Debugging, session 17. This session focuses on how do we test the program, how do we check the benchmarking of our program to how far our program can go, and how to debug the program. So testing for performance, whether your performance, as I said, you suppose you have to go to New York, so whether it is the best path you selected or it is going to be very costly and long affair. So your path, your decision is right or wrong. Unit test and debugging. There are three topics which are covered in the session. More of I'll not go by the logical errors of the program. I'll not even demonstrate the program, but I'll look at the concepts part. Syntax errors are very easy to detect and fix. I will leave those to you. I look at the programs and we'll discuss the approach part of it. Got the point? Testing your code for speed and efficiency is crucial aspect of software development. When code takes too long or consumes too much of a resource like memory or CPU, you can quickly run into a wide range of issues. Got the point? The machine your code runs on can become unstable. Your code can produce unintentional side effects and in some cases even data loss. I mean, the same example which I was quoting just now, same thing. If you look only for the positive side of your program, that yes, in this case this program is successful, and you are overlooking the other aspect, there might be horrible side effects. Making sure to examine clearing performance issues as they rise is helpful, but it is equally as important to establish performance baseline and profiles as well. How can we decide the baseline that this is the minimum or maximum limits of my program can handle up to this level? Code should be tested for functionality from start to finish during the development process. But it is also important to test for performance. Building good habits for testing your code for things like speed and resource utilization while writing it will save you headaches down the road. Alright, we have not discussed this aspect in previous 16 lectures. But since we know a bit of programming now, we can write programs now. It makes sense that yes, we discuss this aspect of the programming now. So benchmark and baseline for Python. There are some libraries that provide flexible ways to do things like performance timing, resource consumption measurements, etc. And they are timeit, line profiler, resource and memory profiler. These are not the only four. You can find out a relevant library of modules for your program and you can implement. As I said, it is just a direction. It is a thinking, it is a mindset that I need to use some libraries for benchmarking and for baseline so that my program is best in not only in terms of providing solutions, but also there is no side effect and performance wise it is best. It is taking minimum resources, maximum output, minimum CPU time, maximum speed. So these are some of the libraries which helps you in testing your program, benchmarking your program, baselining your program in Python. Let's understand one by one. Timeit. Timeit is widely popular for performing quick performance tests. A simple test script and use timeit .timer to run simple time test. Take a look at this program. The program says that yes, test.py is the program name. Import timeit, we are importing the library, import time, and define a function, long functions, print function start and time sleep 5 and print function end. Now you print timeit.time long function and timeit number equal to 2. If you look at this inside our long function, this is just a name, you can give any name here, long function. Inside our function, we introduce some delay using time.slip. Why? Because we are just giving a time for long running task to simulate that. In order to simulate some long running tasks. In order to actually test our function, we pass it to timeit.timer. And here we are passing it. We are calling this with using print statement timeit.timer, and we are passing the function to this method. Timer class measures the overall execution speed of the function. How much time your function took in the execution, during the execution. The number argument specifies how many times the test should be repeated. We are saying 2. So we say, we are trying to say here that this should be repeated twice. This is useful if you have functions that may have even a slight variation in execution time. Repeating the test will build a better picture of speed because we'll have more data to work with. Now, look at this again, this code. This is just a function we are using, but we are using that library to specify that how do we use timeit library to check the time taken by a function in the process of execution. So what we see here is the time taken by a function in the execution. So if it is taking too much of time, you have to optimize it. I'll tell you what you should do, how you should identify that this is ideal time or not. You may not realize it, but I'll give you some direction. There are multiple sorting algorithms here. For example, bubble sort, heap sort, merge sort. There are different types of sortings. Sorting means arranging the numbers or words in alphabetical order or increasing orders of numbers or descending orders. There are many algorithms which we use for sorting. Which algorithm is best? Which approach is best? All are not equally efficient, and those, if you write multiple sorting functions, like you write 3 sorting functions and you want to test which sorting function I should use in my program, this can help you. This test can help you that if you are using bubble sort, it is taking this much of time. If you are using heap sort, this is taking this much of time. If you are using merge sort, this is taking this time. So you can check, you can decide which sorting algorithm is best. Therefore, you can choose which function to use. Right now, this is a simple program because we are not doing any meaningful work. But if you write a function which is doing meaningful work, and there are more than one ways to do the same work, then you can decide which one is better. Because ultimately, at this point, you are just seeing the function which can be used to tell that how much time the function is taking in the execution. And if you know that, then definitely you are open for writing multiple functions which are taking different timing and to decide which function I should use in my program. The output of this program will show the time it can run our function twice and then produce the total time it took. The timeit library is great for performing quick isolated tests on snippets of code, but can also be run from command line as a standalone unit and contains even more useful parameters. Another library is line_profiler. The line profiler library allows you to get the execution time of each individual line in a file. That means every execution line of a program, you can actually find out that okay, these are 10 line of code or 20 line of code. Where did system spend most of the time in my program? Which line took maximum time in execution? Line profiler, as the title itself says, that is going to create profile of every line of your program. It is incredibly useful if you are having trouble narrowing down slow function or third-party calls in a larger file. Seeing the time spent on each line lets you quickly pinpoint issues instead of digging through the line after line of dense code. In order to profile your code, you need to add @profile decorators to each function. Though initially it is time consuming, because it has to create a profile. In fact, what it will do, it will create a separate file which you will investigate by means of a utility. But it will generate excellent report which you can analyze and identify your problem areas in your program, that which part is taking maximum time or which line, which call needs to be optimized. With line profiler, you don't have to import anything or change your code very much. You just have to add a decorator. Decorator here refers to extra functionality which will generate some code or some output and create some file for you to investigate. So we are creating profile @profile. No import, no library, you're just creating profile and using @profile. Now same function we are writing long function, function start, sleep, function end, and we are just executing it. So nothing we have done extra. What will happen when you add this line? Since we got our decorator set up on our slow function, the only thing left to do is to actually test the code. In order to run the line profiler, you have to do two things outside of your code. One is kern profiler, that is KERN profiler -l test.py. So you are executing your program using this utility. In Python -m line profiler test.py lprop. What is this? This file is created actually. This file is created by this program, and now you are analyzing this. Python module line profiler and test this output. So you are creating the profile first here. This is the profile created by this statement number 1, and this is analyzing that profile with the help of line profiler using this utility -m, that is module name line profiler, on this file. The first command in the above will run actually line profiler on your file and generate a separate lprof file in the same directory. Yeah, this is same thing I teach in Linux application programming. There also we have similar profiler, debugger. When you run that, they generate a separate file, and then there are utilities to investigate that output, to check the actual execution time of every line, time spent on every call, and to pinpoint the issues pertaining to the speed and performance of the code. Similar thing is here. In fact, we have the same program which will work for Python also. The library is GDB, that can be used for Python as well. This lprof file contains the results from which the reports can be produced using the module itself in the second command. This is a two-phase process, two-step process. If you run the second command, you will get something like this: unit test, total time, file test.py, function, long function at line number 6, and you see here now which line took what time, and you see the timing and everything here: function start, sleep, function end. So at what time, line by line, your code and time it took. Each line of the profiled function is listed with its detailed statistics. Because we spend so much of time in long function sleeping, it takes up almost 100% of the execution time in our case of the file. Using line profiler to generate a breakdown of where all the execution time is going, let us quickly determine where you may need to focus on refactoring or speeding up the slow tasks. So this gives you the understanding of your program, speed part of your program, performance part of your program, where my program is going slow, where program is taking which call, which line is taking more time in the execution, and then you can focus on and you can optimize it. Then we have third utility, the resource. This resource talks about the CPU time taken by your system. So resource focus on underlying resource implications of running Python code. Being able to tell you how much CPU and memory your code use is almost mandatory in modern environment. You cannot set unlimited CPU time. In fact, let me tell you, microservices framework focus on every module, every component should be quickly executed as fast as possible. CPU time is a very crucial factor because we are working in a virtualized environment. We don't have hard CPUs. We have CPUs which are scalable, on-demand uses. For example, cloud. When you are referring to cloud, when you create anything on the cloud where everything is moving on the cloud, cloud have automatic scaling enabled always, horizontal as well as vertical. When I say horizontal, I am saying adding more number of CPUs. Vertical means adding power to the CPU. It's like horizontal means converting one cat into 100 cats, and vertical means converting a cat into a tiger. And that is generally done by a formula, by a rule. If CPU uses go 80%, then add one more CPU or add more power to the CPU. So silently you are increasing the cost because the program will never crash. In cloud, we say that we have that no limit, no boundary. So that will not be ideal situation because you end up paying more because your program will horizontally or will vertically scale up. So your focus should be the code, that how efficient your code is. That should be the focus area. Setting unbound process off to chew through cycles is taboo and could land you in the world of pain. Correct, 100%. This is what I'm trying to convey. That's where resource comes in. This library will let you measure resource uses in your code and even set limitations on how much a particular resource can be consumed. In this example, we have again modified our existing script in order to pull the resource package. So import time, from resource import get uses and resource uses self. Now we are defining the function, long function, and we are printing get uses, get r uses, get resource uses, and resource uses self. Now this will tell how much CPU time we are taking in this function. In order to put a larger load on the CPU during a long function, we loop over a large range of numbers and force the CPU to perform some calculations. And this is here, we are just doing some calculations. This will produce a higher load than simply sleeping. And when you run this program, you will get this kind of output. Resource structure as uses, run time 152 microseconds, RUS time, that is start time, right? And you see all in the terms of CPU timings, it take various parameters. We need to decode these titles and the meanings of these parameters, what they are representing, the values we have now. We can see this output that we spent quite a lot of user CPU cycles. If you examine the RUU time, that is user time, This figure shows we spent a total of 152 seconds of the time on U time, that is user time. Go back, user time. U time 152, not microsecond, it is seconds. So it is taking too much of time. Not only we can measure CPU time, but some other metrics also give you insight into the things like block IO and stack memory uses of the CPU of the system. So this gives you resource uses of by your program. What happens is we have memory in the form of a pool, but you don't eat up the entire memory for one program. Memory is divided into pages, and each page is given, and you are taking the pages page by page, and you create a stack of memory addresses. Alright, stack means again you put one stack over the other, one item over the other. So as you keep on adding memory pages, you build a stack of memory pages. When you start releasing them, the stack goes down. So stack memory users here refer to the actual memory pages which you are occupying and you are releasing. So you consume and you release. Similarly, block IO, input output on the disk. How much blocks of data is going in and how much blocks of data is going out in IO, that is IO. Then we have another function, memory profiler. Memory profiler is similar to line profiler but focuses on producing stats directly related to memory uses. So this is for memory uses. That was CPU uses, resource uses. This is memory uses. When you run memory profiler on your code, you still get a line by line breakdown, but with a focus on overall and incremental memory uses by line. Just like the line profiler, we are going to use the same decorator structure to test our code. So same decorator, profiler, and same thing here, the body of the function, and we are calling it. So we'll generate the code and execute and create the check the profiler, memory profiler. So here we create a test list and push a large range of integers into it. This slowly balloons the list so we can see the memory uses grow over time. In order to view the memory profiler report, we can simply run python-m memory profiler and the program name. This produces the following report containing the line by line memory statistics. So this is the first line, and you see the size and the memory uses. Here look at, this is taking the maximum time, and when you are using this is taking maximum memory time, memory uses. As you can see, of course it will tell you the memory uses of your program, and when we run it we get this, and we are using 38 MB of memory total. Breakdown given here. This is what is saying. As you can see, our function start with about 38 MB of memory usage and grow up to 41.91 MB after our list is filled. Although you can obtain memory usage information from resource library, it does not produce detailed line by line breakdown like memory profiler. If you are hunting down a memory leak or dealing with a particularly bloated application, this is the way to go. This will definitely going to help you out in the memory. Let me tell you, these are just the names right now, but when you start developing, these are going to be your tools. Then comes the unit test framework. Unit test framework supports test automation, sharing of setup and shutdown code for test, aggregation of test into collections, and independence of the test from reporting framework. The unit test module provides classes that make it easy to support these qualities for a set of tests. The unit test module supports test features. This represents the preparation needed to perform one or more tests and any associated cleanup actions. For example, creating temporary or proxy databases or directories or starting a server process. Then test case. This is smallest unit of testing. This checks for a specific response to a particular set of inputs. Unit test provides a base class like test case, which may be used to create a new test case. Test suite. This is a collection of test cases, test suites, or both. This is used to aggregate tests that should be executed together. Test suites are implemented by the test suite classes. Then we have test runner. This is a component which orchestrates the execution of tests and provide the outcome to the user. The runner may use the graphical interface, a text interface, or return a special value to indicate the results of executing the tests. How do we create? How do we use it? What are the sequence of steps? Step 1 is we import the unit test module in our program. Step 2, we define a function to be tested. In the example on the next slide, we are going to use add function that will be subjected to the unit test. Then create a test case by subclassing unit test dot test case, means this module and this method. Define a test as a method inside the class. Name of the method must start with a test. Each test call assert function of the test case class. There are many types of asserts. For example, calls asserts equal function. Assert equal function compare results of add function with two arguments and throw assertion error if the comparison fails. Finally, we call main method from the unit test module. Run the script from the command line. Step number 8. This is the program. Import unit test. First step. We write a function, add two numbers, return x plus y, and this is the test function, unit test function we are writing. Class simple test, unit test dot test cases. Test add 1. As I said, it must start with the test. Test add 1 self, and we are creating assertions. Self assert equals add 4 and 5. It should return 9. You know what? We call it as test driven development, TDD. TDD says that you write a code. Before you write the code, you write the test. And your function, your code must pass the test. And then you refactor your code to optimize it. So if you look at carefully, you don't need to get inside that, but yes, you can easily make out that we are giving an example that when you are adding 4 and 5, it should give me 9. This is equality. That's why we are asserting that if we give 4 and 5, the function should return 9. If it is not returning 9, then it is not a good program. So here we can write as many assertions as possible. Greater than, less than, means the exceptions we can write in advance. In this situation, it should return this. In this situation, so negative part, the pessimistic part which I was talking about, you write in the form of these assertions in advance, so that your program handles the negative part first, and it goes smoothly. So successful part will obviously will be taken care. The following 3 could be the possible outcome of a test. OK means test A passes and displayed on the console. It may you get to fail, the test code does not pass, and raise an assertion error. Exception F is displayed on the console, and third option is error. The test raise an exception other than assertion error. E is displayed on the console. A, F or E. You can call this program from the command line. The unit test module can be used from command line to run single or multiple tests, like Python-m, that is module name unit test, and you are calling it on your program. Unit test, test module, test class, directly on the class. Test module, test class dot test method. So it supports this command line option. A lot of command line options are supported, which is coming up. For a list of all command line options, you can use this command python -f unittest -h. What all command line options it supports. Debugging is troubleshooting. It's a process of removing errors from the code. It's very easy to remove syntax errors, grammatical errors. You'll find somewhere on internet, but nobody will tell you logical errors. I'll give you the same example of from your place to New York, what are the different modes of transport, what are the different routes available. Nobody will tell you which route is the best for you. That is logical error. So it's like anything else in computer science takes practice. This is something which you cannot, nobody can make you memorize this. You need to have the mindset and the thinking of finding errors, which you have. I've seen that you have. Errors, there are three kinds of errors you will run into. Syntax errors, most easy to detect and troubleshoot. These are errors that occur from poorly formatted Python syntax, because the program itself will tell you that here is the error. Then exceptions. This is what I was talking about. Dr. P.S. Grover gave us. Exceptions occur when you try to do something that Python can't let you do, like access an element of a list that does not exist. These are the most difficult one to detect and troubleshoot. And logical errors. Logical error occurs when your program terminates successfully but just doesn't do the right thing, what you expect it to do. So there comes the role of your brain. You need to get into the code, you need to think it twice, and then you need to correct the code. Syntax errors. These are the easiest kind of errors to debug, as I told you. Look at what Python is telling you. The problem is what. Go to the line Python is telling you the problem is on. Fix the part of your program that is incorrect Python. In some cases, you might have to look at your indentation or the line above the current line where the Python is reporting the error is. Exceptions. Possible regions for exceptions are file not found, list index out of bounds, or expected an integer but not going or got a string. Or fixing these is also not a big deal, because Python will exactly tell what the error is and what the line where or what line it happened on. If a quick inspection of that line does not help you figure out what's wrong, you might want to move on the tricks we talk about on the logic errors, which is the next. Logical errors are the most difficult to handle. Logic errors are when your program simply does the wrong thing. These are the hardest to fix. Typically with a logic error, all you know is your program is producing incorrect output. The trick is to isolate where the error is happening. When all fails, what you should do? You may encounter times when you cannot track down an error that is causing your program to fail dramatically. There are a few steps you can take to recover. First, avoid. Try to write only a few lines of code when then execute a program. You remember in shell scripting, we discussed, I guide. Generally, I give this necessary instruction always. I tell my team members, participants, that don't write the program, build the program. Don't write the shell script, build the shell script. And that is something which helps you, because avoid is writing correct things first and executing only that part of it. Don't build the long line of command in one go. Build the command step by step. Build one step at a time. Write a few more and execute again. Trust me, this has been a very successful model, and I have been always doing this. I cannot write the simple shell script. You give me one script. I remember you give me one script for automating the backup or installation of MySQL on Linux. It's not that the commands were simple. There was no if condition, there was no loop. But it took me 5-6 hours to build that script, because as I said, I built step by step. One line at a time, then next, then clean up, then again. Add one more line, then try, then clean, then try again after a few lines of code. Initially, it takes time to build that. Once you are confident, you go, without fear. Like driving. Slowly, initially when you learn driving, you are very cautious. But when you build confidence in driving, you become fearless. So this is initial stage of development. Then prepare. You should save your program, everything. You begin a new part. That is reach a milestone. Make a backup copy. When you are done, you can copy all your old files into the subdirectory and rename your final solution as you see fit. Yeah, build module wise. Make backup. And I also do this part. Like if I'm writing a script, I'll create 5 versions of it. First, I reach up to here. This up to here it is working fine. Then I write few more lines, and then okay, this is file B. Up to here it is working fine. Then file C. So this gives me way back and forward. That is another solution, another good idea to troubleshoot and debug. Comment out. Yes, this is also another option. You can attempt to comment out a troublesome section of code to see if that is causing the problem. And I follow this also. Then start afresh. When all fails, you can start with a new empty file. Then copy and paste the small sections of your code line by line and build the program. These are simple tips. They require more thinking than the input. And that's all for the session. Thank you very much.